In this talk, Mel Cantor will be taking a close look at the tools we provide for you in the software development kit to build your application with. And equally important, he will be going through the mechanics of building a presentation manager application.
Earlier, we went through the process of constructing the code to build an application, a Windows Presentation Manager application. In this talk, what we're going to look at is the mechanics, the compiling, the linking, and so on. All right, so we're going to look at some of the tools that we have available to us, the compiler, the linker, the editor, and a few others. We'll look at building resources, and those are the menus and the bitmaps. We'll look at building standard libraries and dynamic link libraries. And finally, we'll look a little bit at automating the build when we're done. All right, so let's look at the pieces that we need in order to compile and build an application. All right, so in the traditional way, traditional application or conventional application, what we have is a set of source files, usually in, say, in C or in assembly language. Those are represented by the boxes over on the bottom left-hand side of the slide. And then we compile or assemble the sources that we have. That CC, by the way, stands for C compiler. That's not the command itself for the C compiler. And so we compile or assemble the pieces that we have, and we produce object files. The object files are collected together and given to the linker, right? And we link the object files together, drawing in any pieces, binding in any pieces from the C runtime library and any other libraries that we may have developed ourselves or may have bought. There are standard library packages available on the market, such as a communications package that you can buy and then use the routines in there. We will look at building libraries a little bit later. But anyway, the process is we take the object files and feed them to the linker. The linker takes those object files, resolves all of the external calls that are in there, and brings in the pieces from the libraries that are necessary, and produces a final exe file, which is then a runnable, the runnable program that gets loaded in and then run. All right? In a Windows Presentation Manager application, we will be using the same things. We will be compiling and assembling source programs and producing object files and then linking them and using libraries. In addition to the standard libraries and the C runtime libraries, we will also have dynamic link libraries. We'll show you how those fit into the picture. And we will be producing an exe file. In addition, we have available to us a set of resources which we can also bring into our exe file, into our application. Now, these resources are the icons and cursors and bitmaps that we talked about before. The icons are pictures that are used for representing a running application, or they can be used within a dialog box. We saw one of those in the About box this morning. We have dialog boxes. We can also do things with fonts. We describe menus. We have descriptions for windows. We can also predefine strings. We have some things called accelerators, which are keystrokes that speed up the operation of selection for menus. We also have other user-defined resources, a mechanism for a user to define his own resource. So these resources we need to create and bring into our program also. We will create them. The ones over on the left-hand side of this slide, we have some special tools that will allow us to create them. The other ones, the ones over on the right-hand side, we describe those in the form of a script. So all of the resources, either created over on the left hand, either created with the special tools that we have, or created by describing them in a textual form are all brought together and described or referred to within one file, which we call a resource script file, right, or an RC file. And then those look like this. So we have a resource script file that describes or refers to our resources, either as referring to files or their actual descriptions of the resources themselves within this one text file, which we call an RC file. It usually has the extension .rc. We take that script file and we use that as input to a special compiler called the resource compiler, which is designated by the box in the upper right-hand corner with the RC in it. So the resource compiler takes the resource script file and it produces a binary form of that, which we call the res file or resource file. Then we take that resource file, or in binary form, and we use that as input to the RC compiler again. And in addition, we use our exe file that we created from the linker, right? And the RC compiler then merges, or in a sense appends, the resources onto the end of our exe file. And so we produce a new version of the same exe file, all right, which is then shown over on the right-hand side of the diagram. That exe file is then our executable that is a Windows Presentation Manager application. All right, so the resources and the code, right, are merged together into a new form or a new exe file. In addition, we are missing one other piece. We have the capability within this system of providing more information to the linking process when we're producing our exe files to control the segmentation and how we want the pieces of our program to be manipulated or loaded, or when they're going to be loaded in the system. This file that we use as piece of information to the linker is called a definitions file, or a def file, and it looks something like this. Right? So here's an example definitions file. It has a name and a brief description in there. We can designate a heap and a stack size for it. And in addition, we give some information about how we want our code and data the segments for our code and data to be manipulated or to be used within the system. In this example, I've indicated that the code for our program should be preloaded. So at load time, all of the code will be brought in off a disk, and that the data in our system should be multiple. That is, for every instance or every process created from this code. So for example, if this were a word processor and I had 2 of them running, each of them would have its own set of data. And in addition, we describe what procedures or functions we can both import and export into the application. So in this example, we show that we are exporting our window proc that is going to be used by the Windows Presentation Manager system that makes it callable from the outside. We will also later on show an example where we have some imports where we will list the functions from, say, a library that we want to be able to call from within our code. All right, so the definitions file then goes in here in the part that is highlighted there. That is information to the linker that is then used to produce the exe file before the resources are merged in. All right? So now that we've looked at all of the pieces, these are all of the pieces that are used to, that we need in order to build an application. We will look at the actual creation of the libraries a little bit later on. Right? But so these are all of the pieces. We have source files that we then compile or assemble. They produce object files. We use those as input to the linker, along with the definitions files that defines how our segments are to be used within the application. The linker takes that information and the objects and resolves all of the names that the called names routines that are in there, and brings in the appropriate pieces from the libraries and produces an exe file. The resources are referred to or described within a resource script file. The resource compiler then takes those and translates them into a binary form. The binary form is then input again to the resource compiler with the exe file that had been produced by the linker, and the two are then merged into a new exe file, which is our runnable program. All right? So now that we know how all of the pieces are put together, let's look at the tools and the methods for creating the separate pieces of the objects that are within an application. So let's look first at the process of editing, since that's where our source files and our resource files, resource script files, are created with an editor. As one of the tools that we provide for you in the toolkit is yet another editor for you to learn, if you so desire. We call SDKED, the editor for the software development toolkit. This editor has just about every feature that you could possibly want in an editor. But you're probably saying to yourself, you've used many editors, and you like the one that you have. Do I need to learn this one? Is it worth my time? It's up to you as to whether you want to learn it. My personal feeling on this is that it's one of the best editors that I've ever used. I've used probably, I've lost track, a dozen or so different editors in my career, and of all of them, I like this one the best. And it's customizable. I can completely remap the keyboard into any form that I want. If I don't like the functions the way they have been laid out for me, I just describe to it how I would like the function. It can work with different files in different windows. I can be editing, have two different views into the same file. I can cut and paste between files. I can have different views into different files. It has a complete programmable macro capability, including being able to define standard structures within the C language or any other language that you're programming in. So I can create with a macro an if statement that will put in the words if and the parentheses and put in the braces and the indentation, and then put me back at the appropriate place for me to type the next item of the if. If you have an EGA, it'll support 43 columns. It'll do automatic indentation depending on the language that you're programming in. It does this by looking at the extension on the file name. So if you're in C, it'll indent for C. If you're in Pascal, it'll indent for Pascal. You can do compilations in the background while you are editing another file. The compilations will go on, and if there are any errors, it will report back to you what the errors are, stop you at the exact point in the source code where the error has occurred, and so on and so on. It has almost all of the features that anybody could ever want in a programmer's editor. Use it if you want to. I like it. All right. The next process is the compiler itself. We provide you with a new compiler, C 4.5, version 4.5. It has a few new features and a few new options. We'll look at those individually in a moment. There are other languages that are in the works. As was mentioned before, we talked about Pascal. We're looking at others. They're not available at the moment, but Pascal will be available later on. Right now, the only high-level language that is available is C. So let's look at the new features of the C compiler. The primary one is that it's dual mode. That means that it can run under OS2 in protect mode. It can run under OS2 in the compatibility box. It can also run under DOS 3.x on your old machine. So you can be using this, you can use this editor under DOS 3.x on an 8088 and generate and use it for generating your applications to run under OS2. So the same code will run in either mode. It allows some of the other new features is that it allows some compilation of some larger programs, mainly because it has been optimized itself a little bit better. There's some better optimization in there, so you get some better code generation. It also has the support for the current state of the evolving ANSI standard. So the features for the ANSI standard that are taking shape have been brought up to date with the new 4.5. It has a couple of new language features, one of them being string concatenation. But the major aspect of it is that it's dual mode. It runs in either real mode or protect mode. Right? So let's look at the actual compilation. So here is the command line that one can use for compilation of a program that it's a Windows Presentation Manager program. Note the actual command that I use is CL. In the C compiler, you may use either CL or MSC. If you use CL, which means compile and link, then you should tell it that you want to compile only. You do that with the -C option or /C option. That's one of the most important ones. The other one that you need to be especially aware of is the ZE option, which is about the 5th line down. The ZE option tells the compiler to recognize the keyword extensions, Pascal, far, near, and so on. Remember, we in a Windows Presentation Manager application, our window procs must be far Pascal, so those keywords must be recognized by the compiler. The -ZE turns that particular option on. All right, so now let's look at the assembler. So the new assembler that we provide for you within the toolkit is MASM 4.5. It also has some new features and some options. And I'll describe also that set of C macros that comes with the assembler, with the toolkit, that makes the process of programming an assembly language simpler when you're working with a presentation manager application. So the new assembler has some new features. Again, the primary new feature is that it is dual mode. It runs in both protected mode and in real mode, just like the compiler does. It has now some support for the 386, so it recognizes the 386 instructions. There is some better error handling or more enhanced error handling in there. There's some new error messages that you get. There's a few minor command line options, some new ones, one of them being that you can now set warning levels. It has support for communal variables, which are a way of having uninitialized global data that is both public and external. And most important is that it now works with CodeView, whereas the previous versions did not work with CodeView. Right. So one of the items that we have available is a set of C macros in a file called cmacros.inc that comes in your kit. And using its C macros within your assembly language program allows you to use makes the whole process simpler. It allows you to have things like defining procedures that are similar to C functions. Allows you, for example, to say have a macro called save and give it a register list, and then it would generate the instructions for pushing all those particular registers on the stack. So you can do that with one line within your code. If you're going to use the C macros, then you must include, use the include statement for cmacros.inc as within the program, at the beginning of your program in your source code. So within your source code, at the beginning, before you use any of the C macros, you have the statement include cmacros.inc. Right? So if you are doing a Windows Presentation Manager application and you have a procedure in your assembly language program that is going to be using Pascal calling conventions, then we have a keyword for that within the C macros for that, and that's that question mark PLM equal 1 that says use Pascal calling conventions. And if you want to use those, if you know that that procedure is going to be called by the Windows Presentation Manager system, and you're going to use Pascal calling conventions, then you must include that within your source file, and you put that statement, the question mark PLM equal 1, in front of the include statement for the C macros. So before you include the C macros, you specify the keyword question mark PLM equals 1, and then from then on you'll be using the Pascal calling conventions for any of the macros that you use for building procedures within your code. All right, so let's briefly then look at what we have done. We've looked at the entire process of putting all the pieces together and the editing, compiling, and assembling. All right? At this point then, let's go look at the tools that are available for us for building the resources. So those resources, again, the icons, cursors, and so on, the ones that are on the left-hand side in the left-hand column, we have special tools for. The icons and cursors and the bitmaps are built with a tool called the icon editor. The fonts are built with a tool called the font editor. And for dialog boxes, we have two ways of building them. One is with a tool, and one is by describing the dialog box directly just as text. For the items over on the right-hand side, we do that with text definitions within the resource script file. So now let's look then at how you go about building icons. Right? The icon editor, the icons are built with an icon editor, which is a Windows Presentation Manager application. So it runs under the Windows Presentation Manager, provides you with a drawing window in which you construct your icon essentially by manipulating the pixels on there. It's sort of like using fat bits on the Macintosh. And when you are finished creating it, then you save it to a file which has your icon in it. It has in a binary form, has the information about the icon. You then refer to that file within your resource script file. So that looks like this. So here's your resource script file. Now referring to the icon that you had built with the icon editor, you've given it a number to refer to indicate which icon you're referring to. You can have more than one. And then the file over on the right-hand side to indicate what file, where it should find the information for that icon. Bitmaps, cursors are built the same way with the icon editor. So the icon editor has three modes of operation, building icons, cursors, and bitmaps. So you build the cursor exactly the same way. Within the icon editor, you draw it out on your drawing surface, you save it as a file, and then you refer to that file within your resource script file. Right? The bitmaps, again, are done the same way. You draw the bitmap in the bitmap mode with the icon editor, and then you save that bitmap as a file, and you refer to that file within your resource script file. All right? So the process of building fonts now is essentially the same thing, only this time you use the font editor. Again, you get a drawing surface for drawing the characters out for the fonts that you want to create. You then save it as a file, and you refer to the file within your resource script file in the following fashion. Again, describing it as a font, and then referring to the file that you have saved. For the dialog boxes, we have two tools, two ways of doing it. One is with the dialog editor, again, another tool that is a Windows Presentation Manager tool or application that runs under the Windows Presentation Manager. It provides you with a drawing surface in which you can put the controls, the push buttons, the text that goes along with it, and move those around, manipulate those on the screen, move them around, and position them. When you're finished with that, you then save that as a file, and then you refer to the file or include that file within your resource script file with a special include called an RC include. The RC include includes the binary form of the dialog box that was created with the dialog editor within your script file. Or, if you would prefer to not use the dialog editor, you may define the dialog box as a template directly within the resource script file. So here's a dialog template. You give it a name, describe where it's going to go, and the position of each of the pieces, the text or an icon or a push button or whatever control that you're going to have within the dialog box. You describe where they are to be positioned within the dialog box. Notice that the dialog box has curly braces to a C-type notation to define the different sections of the dialog template. If you would prefer to use Pascal-type notation, you can use, instead of the curly braces, you can use begin-end. Either one is acceptable to the resource compiler. All right, so again, we have two ways of defining the dialog box. One is create it with the dialog editor and then include that within your resource script file, or define the template directly as text within the resource script file. Next item is the menu. And for this one and all of the others, we define them directly only as text or as templates, essentially, within the resource script file. Notice in this one that I used begin ends instead of the curly braces. So either one is acceptable. So to describe a menu, you give it a name, describe how you may use it. In this case, I preloaded it. So at the beginning, when the application first comes up, it will preload the menu that goes along with it when we build the window for it. In this one, I defined two submenus, one called File, one called Edit, and then I defined the items within that submenu, one called New and Open, that would pop down when the submenu was selected. Okay? So menus are defined as text, as a template within the resource script file. All right? We can also have strings. When we built the application this morning on the example application, we had a title bar that said example application. I had defined within the code the title bar, and then I had assigned it the string example application directly in the code. I could have instead defined the string external, or defined the contents of the string external to the program within the resource script file in a string table such as this. And then what I would need to do to get the string into the program would be to load the string. Then the code for that would look like this. I would make a call to winLoadString, telling it which string resource I wanted to use and what was the variable, the name of the variable that is the string itself, and it would then bring the string in and load, in this particular example, the title example application. Right? The value of this, it doesn't save you anything as far as space in your program or anything like that. The value of this is that you have a way of changing your strings either dynamically or when putting together the application. So for example, if you wanted to build a French version of this program, you could put the French version of the strings in your string table like this. Right? And now I have as a title the French version of the title and the French version of the word hello. And then the code for loading the strings would be exactly the same as I had before, only now, so I don't have to change anything within my code. I don't have to recompile my code. I've only changed my resources, and I would have to recompile the resources, but that is a much simpler operation than recompiling the code. You can go even a step further in that if you have more than one string table, say an English string table and a French string table and a German string table, you could, from within the application and say in response to a menu, suppose you had a menu item that said language, and the person clicks on that menu item, it drops down, and it says English, French, German. They click on the French one in response to that message. Then you load the French string table, and everything then would be changed within your program to now be in French. All your strings would be in French rather than in English. So you can do this dynamically within your program. There are some applications out there that do that, allow you to run in, choose the language that you want to run in. Right. We have some other miscellaneous items that you can describe within your resource script file. We have some window templates that are similar to the dialog box templates. And if any of these are not to your satisfaction, we have a mechanism for you to define your own resources. So for example, you might have a large table of information that you need to use as a resource. We have a mechanism for doing that as a user-defined resource. You describe that within your resource script file, and then you run it through the resource compiler. So the resource compiler has two modes of operation. One, to take the resources that are in the script file and produce a binary version of that. And then the second one is to take the binary version of the script of the resources and merge them with an exe file to create a larger new exe file. All right, so, and the mechanism for doing that is just called RC. The -R is the one that says do this with, just translate the thing into a res file, and without the -R referencing the res file, it then merges the resources onto the exe file. Right? So to review briefly, right, what we did now is we've looked at the process of building the source files with the editor and compiling and assembling those, producing object files. And we've looked at the resources, building the resources. The icons, the bitmaps, and the cursors are made with the icon editor. We then refer to them within the script file. The fonts are made with the font editor. We create that, save it as a file, and refer to it within the script file. The dialog boxes can be made one of two ways, either with the dialog editor and then included within our script file, or we can create the dialog template directly as text within the script file. The other resources, the templates, the window templates, and the string tables and user-defined resources and so on are created as text within the resource script file. We then take the resource script file, use that as input to the RC compiler. The RC compiler produces a binary version of that. We then use the RC compiler again to merge that binary version of the resources with an exe file to produce a final exe file that is our runnable program. All right. So at this point, then, let's look at creating libraries. All right. So libraries, we have C runtime libraries. We have libraries that we can purchase from the outside. We have libraries that we can create ourselves, user-defined libraries. And of those user-defined libraries and the ones that we can purchase from the outside eventually, they can be of two forms. They can be the traditional libraries, or they can be dynamic link libraries. So let's look first at the traditional libraries. So to create a traditional library, you write the code for the library routines in C or your favorite high-level language or assembler, or assembly language, and then you compile or assemble them and end up with a set of object files. Right? Then you use a utility called lib, which is a librarian, which is takes the object files and collects them together in a library, which is then given an extension .lib. That library is then used by the linker to resolve any external references that it needs. The code that is within the library during the link process is extracted and bound in or merged in to your executable file. So we actually take a copy of the code out of the library and put it in with your exe file. Okay? Now, dynamic link libraries are built essentially the same way. All right? We write the code in C or assembly language. We compile and assemble them and produce object files. Right? And then we use, instead of the librarian, we use the linker to, with a definitions file, to produce a library or a collection of the code, which is then given the extension .dll. That's the part in the upper right-hand corner. Let's look first at the definitions file that we might have for a library. So suppose I have a library that I've created called My Utilities Library, and in it, and I refer to this as has the name mylib, and in it has a routine that I call utility. Right? So I have a definitions file here that describes how to build that library. So I take all the routines that I'm going to be using within that library. I compile and assemble them, and then I have all of the object files for it. Then I feed it to the linker. Right? And we'll look at that process in a little bit. I feed it to the linker, and in addition, I give it a definitions file that looks like this. This definitions file says, build this library, and give it a .dll extension. Take all the code pieces, give it a .dll extension, and look at the list of the things that are exportable. In other words, what in the library will some application be allowed to reference. In this case, I've said the function utility is referenceable. by any application outside of the library. Right? And I have two ways of designating that particular function. I can either just export the name, or I can export the name along with some unique number to go along with it to indicate that this is the first or the second or the third routine. It doesn't necessarily mean the order of the routine as they appear within the library, but just a unique number to refer to that particular routine or function within the library. This makes the process of finding that routine when we're actually using the library faster than actually just doing a string matching, looking for the name. Right? So with this in mind, so to compile the dynamic link library, here is the compilation statement for that. We need, again, using CL, so I need a -C option. And there are two differences here. The slide should show -ASNU instead of W. In the previous compiling for an application, in the previous look at the compile statement, when we compiled for an application, we could just say -A and a capital S, which indicated that it was small model, near calls, and that SS was equal to DS. When compiling for a dynamic link library, we need to specify that SS is not equal to DS, and it's the U option that specifies the not equal to DS, the one that we want. So we need to substitute for that capital S, the SNU on this slide to indicate that SS is not equal to DS. Assembling is exactly the same as it was before. Okay? So now let's look at the process of what happens when we are dynamically linking that routine that we had just looked at, that utility routine. So there are two times that things can occur with dynamic linking. Actually, there are 4 times when events can occur, and let's look at what those events are and where the linking and the actual referring to the code or executing the code actually occurs. You can, within the development of an application, there is compile time, and then there is link time, link time being when we're running the linker, right? And then there is load time when we're actually loading the program, and then there is run time when we're actually executing the code that is in the program. So in traditional libraries that are created with the librarian, what we do in there is we compile the pieces of the library and save them in a library. And then when we link the application, right, and we have a reference to that item in the library, when we link the application, the linker goes out and finds the piece of code within the library and takes a copy of that code and binds it into our .exe file. Right? Okay? Then when we execute it, that code is right there within the .exe file. Okay? With dynamic linking, we have a couple of other choices in there. We create the dynamic link library, right? And then at link time, what we need to do is we need to provide a method for the linker to resolve the external references, right? And one of the ways that it can do that is from the def file. It gets the name of the pieces that we want to use, to import. So for example, on this particular slide, I have on the top part a duplication or a call in my code somewhere to that utility that is sitting in my dynamic link library. So I'm making a call to utility, right, in the code. All right, so when I compile this code, a reference to an external routine will be created by the compiler. At link time, I need to resolve for the linker where this code is. So the way to do that is in the definitions file for the application itself, I tell it that I'm going to import it. And that's what the piece is down at the bottom of the slide. So this slide shows two separate parts, one being code within the application and the other being information within the definitions file for the application. So for the definitions file for the application, I indicate that I'm going to import from the library, mylib, the routine utility. And then at link time, the linker can resolve that external reference and create the exe file that is necessary. Now notice also in this thing is I have two ways of referring to that utility within that particular routine or function within the import statement. I have, if I had defined it just by name when I exported it from the export statement in the dynamic link library, in the def file, the export statement in the def file for the dynamic link library, when I created the library, if I had just specified the name utility in the exports, then I would have to refer to it in the imports as mylib.utility. If I had specified it with a unique number, then I would use the statement utility equal mylib.1, or the number that was referred to. So either way, either mechanism can be used, but they must match up between the import statement on the applications def file and the export statement on the dynamic link library's def file. Okay? Now, so now I've resolved the references at link time. Right? Now I have another capability. The dynamic link library code doesn't get referenced, does not get bound in at link time like a library, like the other libraries, the traditional libraries that were created with the librarian. So the code there stays in the dynamic link library. All I have done at link time is I resolved the name reference to it. Right? Then, when I load the program, I have two choices for that particular utility. Right? I could say in the def file, right, that I want that one to be loaded, to be preloaded, so that when we load our program, that utility will be pulled in off of the dynamic link library and then loaded in when we start up the application. I could also specify in that the utility be load on call, right? And so at that, what I've done there is I've delayed the actual loading of the utility, of that piece from the library, until I'm actually making the call and executing the call within the code. And at that point, the operating system would bring in the code off of the library if it's not already loaded into memory. All right? So I have a choice then as to when I can actually load the piece from the dynamic link library. All right? Either when I load the application, so that's at load time, by having it preloaded, or I can wait until I actually make the call to the application, and then it will be loaded, do that by specifying load on call, and then that would be delayed until I actually want to use that particular utility. If I never execute that code, then that utility never gets loaded. All right? Now, we have even a mechanism that even goes a step beyond that, another form of dynamic linking at runtime. And this is when I don't know for sure what piece I'm going to be needing. I may want that utility, or I may want some other utility, depending on what the user does. And I want to delay even referring to the particular module until I know by the user's action. So I can dynamically load a module at runtime based on a user's action by making calls directly to the kernel with DOS load module, saying load this particular module. So I have this mylib. I would say DOS load module mylib, right? And then within that, I can do a search for a particular utility, and it returns me the address. So I get DOS by a call to DOS get proc address. And once I have the address of the procedure, then I can call the procedure. Right? And when I'm through with that, then I can free up the module, and that space that is being used within the system for that particular module then is released. Right? So I can delay even the knowing of which particular module I'm going to be using until runtime. Right? So if I use this mechanism, then I do not need to specify any of these within my def file. I do need to have that library or the set of libraries that are available, the modules that are available, and then I make specific calls to load those modules rather than referring to them ahead of time within my definitions file. Okay, so at this point, then, let's look at the process of linking. So we've looked at building dynamic link libraries, and we need to link those, and we've looked at the process building applications, and we need to link those. So let's look then at what we need for linking an application. As we said before, we need a def file to link the application, and so here's another example of a def file. It has name, description, and how we work with our code and data, some heap size and stack size information if we want to, then any imports or exports that we have within the application. All right? Okay. So to link the application, then we have this slide that shows the link statement. Link is a utility that runs is a dual mode application, runs in either real mode or protect mode. We specify to the linker the list of object files that we created, and then we specify the name of the exe file that we're going to create, any map file that we need. Then we list the libraries that we would be using in our in linking the application. So to link our application, we need the C libraries, and there are two of them, slibc and slibc5. The slide has a small error on it, and we will also, since it's a Windows Presentation Manager application, we will need win calls, and since the C library makes calls to the operating system, we will need DOS calls also. Then the final item on there is the definition file that we just looked at that would be needed for linking the application. Right? Then the next item is linking the libraries themselves. So to link the library, we use link again. We specify the object files that we have compiled and assembled. We specify that the file that we are creating is the u.dll, or the DLL file. Then a map file if we want one, and then the list of libraries that we need. Again, we need the C library. In this case, I'm using the small model, so I'd have slibc and slibc5. We would also need DOS calls and win calls. This slide is missing the DOS calls. And then the definitions file for the dynamic link library, which we had looked at before. Right? We have another mechanism that allows us to simplify some of the export and import listing of information. Within the def file for the application, I can bypass the listing of specifically of what I'm going to be importing from libraries, from dynamic link libraries, if I've gone through another step of creating what we call an imports lib for the dynamic link library. We take the def file for the dynamic link library, and we use another utility that is in your kit called implib, and what it does is it takes the definitions, the export list essentially, from that definitions file and produces a name list and gives it an extension of .lib. We can then use that .lib file as one of the libraries that is used in the linking process. And if we do that, then we don't have to explicitly specify the names that we are importing in our applications definitions file. All right, so in summary of that, when we create the library, the dynamic link library, using the def file for the dynamic link library, we use another utility called implib. With the def file for the dynamic link library, it produces a name table or another file that has the names of the portions or the routines within the dynamic link library that the library is exporting. Right? And that file has a .lib extension. We can then use that with the linker when we're linking the application. So we can specify that .lib extension to refer then to the dynamic link library. And then we don't have to explicitly specify the names of the routines within the dynamic link library that we are importing. All right. So we've looked at a lot of different mechanisms and a lot of different files. Keeping track of all of these files seems like it might be overwhelming. We do have a mechanism or a utility that simplifies the process. Essentially, it's called a make utility, similar to the make in Unix. What it does is what you do to use the make utility is to create a file that has a list of dependencies for the different portions of your system that you're putting together. And if it checks essentially the age of the portions of your system and checking the dependencies, it will then do the appropriate thing as to either recompile or rebuild resources or relink or run the RC compiler for only those portions that have changed since the last time you have built the system. So for example, in this case, looking at the top line, we have a .res file that is dependent upon the script file. The resource script file is dependent upon the icon and is dependent upon the header file that is used for that. If any of those have changed, then we will rerun the RC compiler to create a new .res file. Looking at the next one, this says the object files are dependent upon the C source file and the header file. If either one of those has changed, then we will rerun the compiler to produce a new one. And then the last part, if the exe file is dependent upon the objects files that have been created, the res files that have been created by the RC compiler, or the def file. If any of those have changed, then we will relink and run the RC compiler again to do the final merging of the resources with the exe file that is produced. So using this method, if you made a change to your C source code in example app.c, and no changes to your to any of your resources, then you would only need to recompile, and the make utility would make sure that you recompiled the source file to produce a new example app.obj, and then because that has changed, you would relink and then run the resource compiler again to do the final merge, but you would not have to run the resource compiler to create the .res file to begin with. Okay, in summary, we have looked at a set of tools that come with the kit. For editing, we provide you with a new editor, the SDK editor. For compiling, the new compiler 4.5c. For assembling, MASM 4.5. The linker, which is called link. A librarian for building a traditional form of library, which is called lib. The imports librarian, which is called implib, which creates a fairly simple lib file, which essentially just has the names of the exportable routines from a dynamic link library. We use the linker also to build a dynamic link library. And the make utility, a source code control system, simplified source code control system, which is called make. All of these applications are dual mode applications. They can run in either real mode or in protect mode. In addition, we've looked at the resource editors, the icon editor, which is used for icons, cursors, and bitmaps, the dialog editor, which is used for building dialog boxes, the font editor for building your own fonts. These three editors are Windows Presentation Manager applications. They only run in protect mode, and they only run under the Windows Presentation Manager. In addition, we looked at the RC compiler, which takes a resource script file and produces a binary resource file, and then also does the final merging of the resources with the .exe file to produce your final runnable application. Thank you very much.
For additional information on the topic we just covered, be sure to take a look at the written questions and answers that accompanied this videotape.